Welcome to this tutorial explaining how to use MetaboLab within the Phenomenal Galaxy installation. The public website for the Phenomenal Galaxy installation is given here. It's a fairly typical Galaxy installation, so on the left hand side you have some tools. At the top we have some fairly standard tools for importing data and then manipulating it into the right format required for subsequent tools. So the phenomenal tools for processing and analysing metabolomics data are given here. There are a number of submenus, for example an NMR submenu and a mass spec submenu, where metabolomics tools specific for processing NMR or mass spec data are located. I'm going to show you how to use MetaboLab within the Galaxy workflow on my local installation, which hopefully you can see looks much the same. On the public installation, MetaboLab will be within this NMR submenu, but I don't know where in the list. Okay, so if we follow the MetaboLab link, the tool is opened. If you look at the top here, hopefully you can see that two files are required for MetaboLab. The first is the raw vendor data in a zip file. The second is the script that controls how the data is processed. So we need to get some example data. So there's a working example down here. So we firstly download the raw vendor data. And secondly, we'll get the script. So we do Control A, Control C to select and then copy the data. So I'm going to paste that script, that text, into a script. Okay. So now we have the zip file and the script locally. Okay, we need to upload those files into Galaxy. So if we click on Upload, they're in my local downloads directory. So if we get the script, and we'll get the zipped data. For the zip file, you need to select Zip, as sometimes the auto detect fails. And click on Start. When the files have been uploaded into the Galaxy installation, they go green. When they become available within Galaxy, you can see that the software recognises that the testdata.zip is a zip file and suggests it as a possible file here. Similarly, this myscript.ml is recognised as a text file and is suggested as a possible MetaboLab processing script. Okay, so when we're ready to run, we just click on Execute. That will take a few minutes to run. Whilst it's running, I'd like to show you a little bit about the script that's used to control the processing. So I have two different data sets which have a different different data structure for Brooker data, and the scripts have to be modified accordingly. So the first example have a zip file called testdata.zip. When this is unzipped, 4 directories are produced. If we look inside those directories, so each data set only contains one experiment number 10. Okay. So let's have a look at how that data is processed. So a lot of what's in this script you should not initially change. it's very, very important that wherever it says data path, wherever the path is specified, you leave it as /mydata. So here it begins, the data path begins /mydata, and then we have those 4 directories. One has the prefix ADG 19007U _ 404, and the other 3 begin with this alternative prefix, and then 116, 117, 118. So that syntax will select those 4 directories. The experiment number is always 10. Okay, so if we go on down through here, there's a lot of parameters to control for processing. I'll explain about those in a second video. But here, where it says export path, you must leave that as /mydata. Don't change that. Don't change the name of the export file. And finally, at the bottom here, there are some other paths and file names that you shouldn't change. So leave the ISOTAB files as they are, and leave the path and file name of the process data as given there. If I show you the other data format, okay, so here we have a zip file which, when unzipped, produces one directory called Brooker_data. If we look at what's inside that, we can see here that this, in this data structure, there's one data set, but within it there are multiple experiment numbers. So we need a script that can cope with this, this alternative processing. So we're particularly looking at the data path bit. So here, again, the data path must begin /mydata, but then it continues Brooker_data, and the data sets are 1, 3, and 5. You could have just written all, or you could write odd, or with different experiment numbers you could write even. Okay. As before, you mustn't change the paths throughout must begin /mydata, and don't change the names of the output files in this script either. Okay, so let's see. Okay, so whilst I showed you that, the job has been completed. Hopefully you can see there are now a number of files that have been outputted from the tool. So for example, there's an intensities file for Batman. So you can see there's a series of ppm values in column 1, and then a series of intensities for each of the 4 different spectra. There's also zipped ISOTAB files for metabolites. So if you want to submit your data to metabolites, this will give you the ISOTAB files that you need, although you may need to add metadata to that within IsoCreator. There's also a map file containing the process data, which you can read into MetaboLab, the normal graphical user interface version of MetaboLab, or into MATLAB. There is zipped Brooker process data, and there is a smaller map file that contains the pre-processed data ready for analysis using MATLAB's PLS toolbox. If you want to have some further information about MetaboLab and how to use it, at the bottom here there are some links to videos to explain about the scripting. So I think that concludes this tutorial explaining how to use MetaboLab in Galaxy. Thank you.